Hello, thank you for joining us. We are Texas Southern Solar with Texas Southern University, and this is our University of Cheyney solar proposal. My name is Andrew Green. I'm an electrical and computer engineer, senior at TSU.
Hello, thanks for joining. My name is Dumo Jack Tony. I'm from Texas Southern University, and I'm a senior. My major is civil engineering, and my minor is design technology.
First of all, can you hear me? Yes.
Yeah, Jerry, you and Duma were both a little bit on the quiet side, so if you could be a little bit closer to your microphones, that would be helpful.
Oh, okay. You can hear me now?
Yep, I can hear you fine.
All right. My name is Jair Alexander Harris. I go to the DLFG Texas Southern University. My major is computer engineering technology with a focus in computers, computer engineering, of course. And I'm a junior, so hi.
My name is Michael Magana. I'm a senior. I'm currently a electrical engineering and computer engineering major with a focus in electrical engineering.
Hi to everyone. My name is Isaac Bovern. I'm a computer and electrical engineer at Texas Southern with a focus in electrical also. And I am a senior.
Hello, my name is Lamorris McClellan. I'm a civil engineer at Texas Southern University.
All right. Come on. Come on.
All right, can you guys hear me?
Yep.
All right. So the background. Cheyney, Pennsylvania is the first oldest HBCU in the United States. It was established on the 25th of February, 1837. Next slide, please. So these are the sites we are working on. Working on the east side, which contains buildings with high energy use, namely the science facility, laboratory, and the rooftop space, the rooftop space is really limited, but there is significant opportunity to mount PVs and ranking canopies. The west side, which is on the right, is our area 2, which includes the residence hall, dining hall, parking lots, and wastewater treatment plants. PVs can be designed on the rooftops and parking lots, and also the geothermal field, which is southeast along the Cheyney Road. Next slide. So our system goals. Next slide. Cheyney's the climate action plan. We want to reduce. Basically, we want to go green. So we want to reduce campus consumption of natural gas and electricity, and eventually achieve carbon neutrality in the future. What are our expectations and plans? Well, like I said earlier, we want to go green, want to reduce emissions and offset grid purchases, deliver considerable value to the community. So by offsetting the purchases, we want to make it affordable so it will be supported by the community. And we want to showcase Cheyney's initiative to green energy. Next slide.
All right, so here we go with the design theory. Next slide, please. Of course, we're going to talk about the local laws, building codes, and Cheyney's expectations. To make sure that the PV system is complacent with the Pennsylvanian code and codes and laws, built within the parameters given by Cheyney University. Codes and laws complies with PN laws and zoning restrictions, setbacks set and building restrictions in or are placed, which means that what we build in the system will be in the on the property. Electrical code complacent, Chapter 23 Solar Energy System, Section M2301, Title 34, Chapter 403.1 of the Pennsylvania Code, expectations 1 MW system code, battery soaking solar generation, worth of investment return, showcasing an initiative to utilize renewable green energy and innovation. Next slide, please. So the panels that we have chosen are for Sonalia Solar, which can hold 335 watts, optimum operating voltage per, oh my God, 38.6 voltage, optimum operating current 8.8 amps, dimensions 1,954 by 981 by 40 millimeters. I'm sorry, I'm talking really fast. Next slide, please. The inverters are we're getting from Sunny Tri-Power Core inverters, 50 kilowatt inverters, input DC, maximum system voltage 1000 voltage, rated MPP voltage range 500 volts to 800 volts. Minimum DC start voltage is 150 volts to 188 volts. Output AC nominal is 50 kilowatts. Maximum current apparent power 50 kilowatts voltage per amp, and nominal AC, which is 480 voltage to 277 voltage. Go ahead, next slide, please. Of course, and we're gonna have to talk about the battery. The battery optimization used via Reopt, 5.2 hour blackout campus support, which means that if you already know. Your recommended power, battery power and capacity, which is 183 kilowatt battery power, and your battery capacity, which is 954 kilowatts per hour. Next slide, please.
Okay, and now we'll talk about the system description, which is the PV system created using Aurora Solar. Next slide, please. Okay, for an overview of our system description, for the system sizing, our PV system utilizes 2,962 panels. It has 3 carport systems and 3 rooftop PV systems. In the pictures below, you can see in the highlighted color magenta, these are where our PV systems are going to be made. For the system capacity, it produces a total of 992.3 kilowatts. The carport systems produce 603 kilowatts. The rooftop PV systems produce 389.3 kilowatts with a total production of 1.14 megawatt hours. Next slide, please. For the west side of our PV system at Cheyney University, we have the Ada George Dining Hall roof PV system. This is the 3rd highest consumption building on the campus and is a very high traffic area. So it's going to be very cool to see the students interact with something that they see every day. The rooftop system composes of 426 panels, generating 142.71 kilowatts of power, being strung together with 3 inverters. This rooftop system has high solar access, and using Aurora's TOF components, there were no tilt was necessary. Next slide, please. Okay, to complement the west side, we also have visitors parking area E ground mounted PV system. This is a parking canopy that is going to be on the main entrance of visitors parking. It has 1,186 panels, which generate 397.31 kilowatts. It is being strung together with 6 inverters and has very high solar access, with the lowest amount of solar access, which is on the bottom, being 90% for those panels. Next slide, please. Moving on to the east side, we have the Hill Library roof PV system. This building faces towards road traffic and also the historic district attraction, which is a historic district neighborhood and also a historic farm that is an attraction for tourists. This rooftop system has 484 panels. It generates 162.14 kilowatts of power and is being strung together with 3 inverters. Next slide, please. And for the east side of the system description, we have Cheyney's newest building, which is the new Science Center roof PV system. This building has the highest consumption on campus and will be a great initiative showcase for Cheyney pushing towards their greenhouse and their green initiative. The system consists of 135 panels, which generate 45.23 kilowatts of power and is being strung together with 5 inverters. Next slide, please. To complement the brand new science building, we also have the new Science Center parking ground mount system, and it's a employee parking canopy for the new Science Center, and it's just extending PV exposure around the new Science Center. It's consisting of 158 panels generating 52.93 kilowatts of power and is being strung together with 1 inverter. Next slide, please. And for the last of our parking canopies, we have visitors parking area B. This is facing towards University Circle, which is a street that goes directly through Cheyney. So everybody driving through Cheyney, going to whichever parking lot they would like to go to, would be able to see Cheyney's initiative and really boost morale in the community and push and just have a heavy influence for solar generation for everybody that sees this. It consists of 456 panels, generating 152.76 kilowatts of power, and is being strung together with 4 inverters. Next slide.
Next, I'll be talking about the development plan. And so beginning on June 6th of this year through August 7th of this year, we'll begin the drafting and the engineering design.
Michael, you're a little bit quiet to me anyway.
I could come a little closer. So beginning on June 6th of this year and August 7th, we'll begin the drafting of the engineering design, also reviewing different construction bids for construction labor, as well as the materials required, also appropriating the funds for installation. Beginning on August 7th of 2022 through November 6th of 2022, we'll be procuring the necessary materials, equipment, and tools, and ensuring that all construction falls within the right local and state codes that are necessary. Beginning on November 7th of this year through September 14th of 2023, the construction and installation of the PV system will begin. And on September 5th of 2023, the construction completion will occur and the system will go online. Here's the financial analysis for our system. And so the cost breakdown is as follows.
Michael, I'm sorry, I don't know if it's just me, but I really am having trouble here. Are others hearing
I can
Michael
hear
fine?
him fine.
Okay. And so the cost breakdown is as follows. For the inverters, the cost for the inverters will come out to be $47,040. For the panels themselves will be $853,500. The cost for the battery will be $300,000. The cost for all of the proper building permits will come out to be $48,000. As far as construction goes, the carports will come out to be $407,000. The mounts for the Ada S. George Dining Hall come out to be $356,700. The mounts on the Hill Library would be $405,300. The new Science Center mounts would be $113,000, and the total construction cost for labor would be $1,282,000. And the total cost for the entire system would come out to be $2 million or $2,560,540. I think I may have lost control. Oh, there it is. Okay, and so our energy usage savings is as follows. Using REOP, we were able to find an initial return rate of 22.5%, with the levelized cost of energy being 0.003 cents per kilowatt hour. As you can see on the slide, the total annual cost for utilities is about almost $400,000 per year. And with our PV system, the campus would be saving about $100,000 annually with our PV system.
I'm sorry, I moved my mouse. Yeah,
there it is. And so we are opting to use a PPA contract with Sonali Solar. There's no upfront cost necessary for the installation. Arrangement of the financing to fund the PV system costs, build and maintenance operation for the length of the contract. And in return, Cheyney will be able to buy their electricity at a lower price. And at the end of the contract, the PV system can be purchased or a new PPA contract can be established. With incentives being as low as 0.057 cents per kilowatt hour. And some incentives that we are able to get as well too, as the Pennsylvania Alternative and Clean Energy, ACE, which allows for loans and grants issued for every new job within 3 years of the approval of the PV system, up to $5 million or 50% of the total cost. There's also the High Performance Building Incentives Program, which grants up to $50,000 or $500,000 or 10% of the total building cost. And there's a Keystone Initiative, which allows for a tax credit for up to $15 million in tax credits.
And an overall summary of the highlights of our system and system design can be found here. Next slide. Producing at about 1.14 megawatts per hour of production with our system, over using mainly the 6 buildings that we have on each side of the campus on the east and west side. The most notable being the visitors carport, which will be posted on the west side with at around 1,200 panels in total, producing the most of all the buildings at 600 kilowatts. Also, with this, we went ahead and went more towards a stylistic approach with this. So with those carports and the science building in itself, just trying to showcase us, well, not us, but Cheyney as going for that initiative, that innovative green energy initiative, showing their drive to be green and stay green for this at least a lot of time with the PPA, and hoping to get a low PPA cost and amount in total. Still trying to continue and save that around $100,000 per year, and $100,000 per year, with the total amount of our system being around $2.5 million in total, including cost of parts and labor. And that will be all, and we will be open for questions at this point.